Today we're going to talk about how to shift the sine and cosine curves horizontally. So what we have here is a normal sine curve, and what we're going to do is we're going to add a value to x. If you look down below, you see that this is the sine of x plus c. If you look at the little slider I'm about to move, I'm going to move this slider so the value of c changes. And notice, watch what happens to the graph as I move it. As the value of c changes to 17 degrees, 18 degrees, 24 degrees, the graph is shifting to the left that many degrees. So if I were to come over to, let's say, 45 degrees, this graph has now shifted to the left 45 degrees. So let's take a more careful look at that. So notice in this graph that what was the sine curve, and it started on the x-axis at the origin, has now moved to the left here to 45 degrees. In fact, the whole graph has shifted 45 degrees. So where the maximum point was, what used to be at 90, now it's at 45. By the way, this over here is shifted to negative 45, not positive 45. The entire graph has shifted. So whereas it usually hits the crosses the x-axis at 180, notice over here it has shifted to the left 45 degrees, so now it's at 135 degrees, and so on and so forth. So the graph shifts to the left as we increase the value of c. Let's take a little more careful look at that. So once again, as I increase the value of c, watch how the graph keeps shifting, 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 and finally, we're almost at 90 degrees. Almost. There we go. So at 90 degrees, notice that it now looks exactly like a sine curve. So that's an interesting, that's very interesting here. If you notice that the sine curve and the cosine curves are really out of what's called out of phase by 90 degrees. In fact, let's take a look at this. Normally when you look at this curve, you'd say, oh, but of course it's a cosine curve. But what we just discovered is, yes, it can be y equal to the cosine of x. But it just as well could be y equals to the sine of x plus 90 degrees. So you actually have two possible equations for this graph. Actually, it's an infinite number of possibilities because, well, let's just take a look again. I'll show you why. So here we are at y equals the sine of x plus 90. So let's keep moving to the right. What we're doing here is we're trying to manipulate the graph so it has moved over to be yet another cosine. You'll notice that we were at 90, and as I keep increasing the graph keeps shifting to the left. And what I'm trying to do is get to look like a cosine curve again. So if I get close, there's, oh, I was at 450 and I moved too fast. And so here we are at with c equal to 448 degrees. I had a little difficulty getting into 450, but it's almost at 450. And notice what happens. It looks like the cosine curve again. So if I move over 90 degrees, if I add 90 degrees, I have it be a cosine of, it looks like a cosine curve. But if I add another 360 to that 90, it also looks like a cosine curve. So if we go back and look at what we had before, this graph here, which looks like the cosine of x, or the y equals sine of x plus 90, can actually be the y equals the sine of x plus 90 plus 360, or 450. So in every case, if you notice that by adding a value to x, the graph shifts to the left and actually will look like a cosine curve at 90 degrees when shifted 90 degrees to the left, or shift another 360, which will make it 450 degrees. And we could, once again, shift it again, another 360, and it would also look like the cosine curve. Now, of course, now the question comes up, what happens when we shift the graph to, we add a negative number to the graph, to x. So let's say we add a negative number. Let's try to make it 45. And there's 45. And notice the graph has now moved 45 degrees to the right as opposed to the left. So this would be the graph right here of the sine of x minus 45 degrees. So we just put the graph over here. Notice the graph has now shifted to the right 45 degrees, because what we did was we added a negative value to x. In this case, it was x minus 45 degrees, and the graph shifted to the right. Let's look at one more. So if we continue shifting the graph by adding a negative number, a smaller negative number to x, the graph continues to shift over until, in this case, we're going to get to just about 90 degrees. And there we are. We have now shifted the graph to the right 90 degrees by adding a negative 90 to x. And here's the graph. We can make it a little bit bigger so you can see it. And this is the graph y equals the sine of x minus 90 degrees. And once again, notice the graph is shifted to the right when we add a negative number. So why don't we summarize what we just learned? So in this case, we notice that when c is a positive number, in the graph of y equals the sine of x plus c, and by the way, this could be the cosine as well. Graphs are very similar. That when c is greater than 1, the graph shifts to the left. As in this case. So when c is greater than 1, in this case it's a plus 90, the graph has shifted to the left that way. However, when when c is less than 1, as in this example, when we have y equals the sine of x plus c, or y equals the cosine of x plus c, when c is less than 0, the graph shifts to the right. And we should make one correction. In the previous example, we did not mean that when c is greater than 1. We meant when c is greater than 0. So let's just fix that. So in other words, when c is a positive number, the graph shifts to the left. But when c is a negative number, the graph shifts to the right. And now it's your turn. We'd like you to find a sine and a cosine equation for each graph. So take a look at this, pause it, and good luck, and I'll see you again next time.